Hi and welcome to Demon Questions from OnMaths, where we look at the more challenging GCSE maths questions. Enjoy! Hi and welcome to Demon Questions from OnMaths. So, in these sessions we are going to be looking at the more challenging questions. Now these are the AO2, AO3 questions in teacher speak. In other words, the ones that are unusual, are difficult, the ones you open the exam paper and go, I've never seen this one before in my life, how am I going to do this? Hopefully you'll have all the skills, and if you don't, then you go to onmaths.com and brush up on your skills, but you should have all the skills to be able to answer the question. In these videos we're going to show you strategies to be able to work out a question, work out what you're going to do, work out how to get the first mark, work out how to get started with these questions. The difficulty is you look at a really complicated problem and you go, oh, I can't do this at all. And yet there's a circle there you could work out the area of. There's a part of it you can kind of understand and you can get the ball rolling. They are very generous with early marks on this, and on the foundation this is worth 25% of your marks, on the higher 30% of your marks. So it's a big chunk of marks that this is worth and we need to be getting. We're also going to be looking at more wordy questions, which again on the foundation is 25%, on the higher is 30%. And this is you're expressing how you find out a method, you're proving something potentially, or you're showing why Jimmy is correct and all those kind of questions. So the way I structure this is there's 20 marks on each demon paper. We're either doing non-calculator or calculator, higher or foundation. And within those 20 marks, I've evenly distributed the topics and I've evenly distributed the grades. So it starts at a low grade and gets higher. I've also put the grade boundaries on so you can roughly estimate whereabouts you are. I hope you enjoy. Thank you. I hope you enjoyed that video, and if you really liked it, click like. If you really liked it and want to see more, click subscribe. All these questions are on our website, onmaths.com. So if you go to onmaths.com, go to Demon Questions, you can have a go on this paper yourself. Obviously the numbers change like everything on OnMaths, so you can keep trying it again and again until you get full marks. Thank you very much. For these types of questions, always make sure that you show your working. Show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these two are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding because they won't accept any other word. So I can solve this by first of all adding 50 to both sides. So that's 2y equals 102, and then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51 degrees. Now I know that this is 52 degrees because if you look at this, and I'll use a different colour, this angle here and this angle here are Z angles or alternate angles, or you can say that this 52 degrees here is equal to this here, which is also 52, because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103, and therefore that's going to be 77 degrees. So my answer is 77 degrees. Okay, so this is quite a complicated looking question, but the most important thing is we break it down. So it says a circle is drawn inside a square. The square has a height of 12 centimetres. So the first thing to notice is it's a square. Therefore, the width is also going to be 12. And be careful to look out for that. Whenever you've got a square, they might only give you one of the dimensions. They won't always say it's a 12 by 12 square. Okay, so you've always got to assume that the other one, or you've always got to know that the other side is going to be the same. Okay, it says work out the shaded area. So the thing we notice is it's like a quarter of the square but with the circle removed. Okay, so the first thing to do is work out the area of the square. So area of square. Okay, so the area of the square is going to be quite easy. It's going to be 12 times 12, which is 144 centimetres squared. Okay, next thing to work out is the area of the circle. Okay, now this you need to remember the formula, which is pi r squared. Okay, and that you do need to know because you're not given that in the exam. So it's going to be pi times, and now what is the radius of that circle? So the radius is halfway across the circle. Now the circle has the same height as the square, or the same diameter as the square's height. Okay, so the radius is half of that, so it's going to be 6. So it's going to be pi 6 squared. 6 squared is 36, and we write that as 36 pi. Okay, now it's an uncalculated question, or it could be in the non-calculator, it could be in either. Okay, but it does ask us to give our answer in terms of pi, so we're not going to go any further than that. We'll leave it as 36 pi. Okay, so we need to work out the area of all of the outside. Okay, so we're going to do all of the outside. Okay, including this shaded bit. Okay, so area outside circle. So I'm trying to show the examiner that I'm working out the area that I've shaded in red. So the area of that is the area of the square, which is 144, take away the area of the circle, which is 36 pi. Okay, now to work out the shaded area, which is what the question asked for. Now looking at that, we've got 4 parts. We've got this part, this part, this part, and this part, and all 4 of them are equal, and we only want one of them. Okay, so to work out the shaded area, we get our answer from before and we divide it by 4. So we're going to divide the 144 by 4, and it's dead easy to divide by 4 because you halve it, then halve it again. So half of 144, well, half of 140 is 70, half of 4 is 2, so that's going to be 72. Then half of 70, half of 72 is going to be half of 70, which is 35, half of 2, which is 1, so it's going to be, what did I say, 36. So it's 35 plus 1, which is 36. Okay, next we're going to halve the 36 pi. So we only need to halve the number before the pi, and that would have the same effect. So we're going to halve 36, or we're going to divide it by 4, but we're going to halve it first, which is 18, then halve it again, which is 9. So we need to divide each one by 4. So I've divided that by 4 to get to 36, and I've divided that by 4 to get to 9. So my answer is 36 take away 9 pi. Okay, so this looks like a quite simple question, however it's a little bit more complicated than it looks. It says that the sum of 3 consecutive numbers is divisible by 3, and we've got to prove it, so the working out is everything. So I'm going to name my first number x, okay, because we don't know what it is, it could be anything. But the next number will be x, same as the number before, but 1 added to it. And the next number after that is going to be the same as the first number, but 2 added to it. And it says the sum, so what we're going to do is we're going to add these 3 numbers together. So x plus x plus x is 3x. 1 plus 2 is 3. Now, this hasn't proved that they're divisible by 3 yet. All I need to do now is factorise this out. So I'm going to divide each of those by 3. Now, that now is proof that they are divisible by 3, because if you times any number by 3, it will be in the 3 times table. So my proof is this bit here, and I could write a sentence saying any number that I times by 3 will be divisible by 3. And on the site, that's all you need to put in. Okay, so in this question we're given a rule, which is in this box here, and it says we're going to add a number, which we're going to call k, and then multiply by 2 to get to the next term. So I'm going to ignore the a for now, and I'm just going to look at the 30 and the 72. So we've added k to 30, and then we've multiplied it by 2. Now the important thing to highlight here is we multiply all of it by 2, and that gives me the 72. Okay, so all I need to do now is solve this and find out what k is. So I'm going to start off by dividing both sides by 2. So we've got 30 plus k equals 36. And then we're going to take away 30 from both sides. We've got k equals 6. Okay, so now I'm going to have to work backwards. So I have the 30, and I want to find out what a is, which is the first term in this sequence. So working backwards from the 30, I need to divide by 2 first of all, and then it says add k going from left to right, so I'm going to take away k, which we know is 6. So 30 divided by 2, and then we're going to take away 6 to find out what a is. So half of 30 is 15, 15 take away 6 is 9, so a is 9. Now you can check this easily. We can do 9 plus 6, which is 15, times 2 is 30, and then 30 plus 6, which is 36, times 2, which is 72. Okay, so the first thing to do in this question is notice that we've got a bracket squared and another bracket squared. So the first thing to do is you need to write those brackets twice. If you don't do that, you end up squaring the 3 and squaring the root 2, and then thinking that you're going to get the right answer. Unfortunately, you can't get the right answer with just squaring the 2 of them, because they are quadratics. So I'm going to write them out as 2 brackets, because anything squared is itself times itself. Okay, now we're going to expand these. Now, I'm not going to go into the methods of expanding quadratics, but we've got loads of videos on our channel, on our website, to help you with that. So use whatever method you are comfortable with, whether it's FOIL or smiley face or whatever you want. I'm going to put them into brackets though. So 3 times 3 is 9. Then we've got plus 3 root 2 plus 3 root 2, so plus 6 root 2. And then we've got root 2 times root 2, which is plus 2. Okay, so second one, 3 times 3 is 9. And we've got minus 3 root 2 minus 3 root 2, which is minus 6 root 2. And then we've got minus root 2 times minus root 2. 2 minuses make a plus, and root 2 times root 2 is root 2. Now, the reason I kept them in brackets is because this is really important. There's a minus 1 there, and it means we've got to multiply everything in the second bracket by minus 1. So the first bracket's unaffected, so we're just going to get rid of the brackets there. Don't need to worry about that. But the second bracket, I need to times everything by minus 1. So that first one is minus 9. The second one is, well, minus times a minus is a positive 6 root 2. And then a minus times a positive is a minus, so minus 2. That means that we can cancel out the 9s there. We can cancel out the 2s there. And all we're really collecting here are the roots. So 6 root 2 plus 6 root 2 is 12 root 2. Now it says it wants it in the form a root b. So a is the number outside the surd, which is 12, and b is the number inside the surd, which is 2. Okay, so this doesn't seem like the easiest questions, because there's 3 shapes going on. There's no numbers in it at all, and we're asked to find a formula. So the first place I'd start is working out, well, first of all, what are the formulas we'll need? Well, let's have a look. So we've got a hemisphere. And some of these formulas you will be given. So a hemisphere is a volume of a sphere and then halved. So instead of 4 over 3, I can just say 2 over 3, which is half of 4 over 3, pi r cubed. The cone that we've got is going to be 1/3 pi r squared h. And then the cylinder we have is the area of the circle times the height. Okay, now we need to find out what the bits are. So for the hemisphere we just need r. Well, that's quite simple because r is just going to be x. It's the radius of the hemisphere. Okay, now what's more difficult is to work out the height of the cone. Well, if the radius across to the right is x, the radius of the circle up is also going to be x. So we know the height of the cone is going to be 4x because one of those x's is used on the hemisphere. We know the radius of the cone is going to be x because it's stated at the top. So let's keep going. The radius of the cylinder is going to be 10x. And the height is just labelled as h. So that's nice and simple. Okay, now let's have a look at what this question's saying. It's saying that this thing here is going to be melted down and is going to be used to create this. So that's just saying that the volumes are going to be the same. So if I add the volume of the hemisphere to the volume of the cone, it should equal the volume of the cylinder. Okay, so we know that a hemisphere plus the cone volume, and I should write volume here, show the examiner that I'm working with volumes, equals the volume of, I don't know why I wrote an S, my goodness, C for cylinder, wow, tell my maths teacher, right, cylinder, there we go. So hemisphere is 2/3 pi, and we said that x was the radius, so x cubed, brilliant. So plus the cone, now what did we say the height of the cone was? We said the height of the cone was 4x. So it's going to be 1/3 pi x squared, because the radius is x, and is it 4x? Let's double check that. Always double check. Yeah, it is. Okay. So the cylinder, and I'm going to leave that up so I can see it, is pi, and what's the r? So pi times 10x squared, and all of that squared, because all of that is r, times the height, so times h. Okay, so this is the formula we've got to work with. I'll put my lines down. Okay, so what we got? Let's sort out the timeses first, and let's tidy this up. So that hasn't got any timeses in it. This we're timesing it by 4, so it's going to be 4/3 pi, and I'm timesing it by x, so that's going to be x cubed. This one, I'm doing the 10x squared, so I need to square the 10 and the x, so it's going to be 100. And let's do the pi next, pi, and it's going to be x squared h. Okay. Now, if you notice on the left-hand side, these two here are the same. They're both pi x cubed. So we can just add them together. So it's going to be 2/3 plus 4/3. So that's going to be 6/3, or just 2. So it's going to be 2 pi x cubed equals 100 pi x squared h. Brilliant. Okay. Now let's just check to see what it wants. It wants a formula of h in terms of x. So it wants h equals. Okay. So first thing I need to do, well, let's have a look. What's easy to do? Well, what's easy to do is just divide both sides by pi. Let's get rid of the pi's. So 2x cubed equals 100 x squared h. Now we want h on its own, so we're getting close. We need to divide by the x squared first to get h on its own. So I'm going to divide by x squared. So we get 2x equals 100h. So we can already see we're really close. So to get h on its own, we need to divide both sides by 100. And that's going to be 2x over 100 equals h, or h equals, and we can cancel the 2 and the 100. We can divide them both by 2, equals x over 50. So our answer is h equals x over 50. I hope you enjoyed that video, and if you really liked it, click like. If you really liked it and want to see more, click subscribe. All these questions are on our website, onmaths.com. So if you go to onmaths.com, go to Demon Questions, you can have a go on this paper yourself. Obviously the numbers change like everything on OnMaths, so you can keep trying it again and again until you get full marks. Thank you very much.